morning, my name is Gary and welcome to my shop. First of all, I'd like to congratulate those of you that survived the introductory music and made it this far. I'm sure there's a few people that are off looking for other YouTube channels to look at now, and that's fine with me. It's been a while since I've been out here, and a number of things have happened that have prevented me from getting here. It's a busy time of year in at work, and then last weekend I was expecting to be out here. Got a little bit of snow, but the snow disappeared. That wasn't a problem, but we did have some issues in at work, and I ended up having to go in for the weekend and work a couple 12-hour days, so I really didn't get a break. Another thing that's held me up is I knew that I needed to get a little bit of metal to work with to finish this project. I ordered the metal from a reputable eBay supplier, and when this 11-pound box arrived, it weighed about 11 ounces, and all I had inside was packing material. And it's kind of an interesting history on the shipping on this. The seller shipped it. It didn't appear with a tracking number for a week. I finally contacted the seller and said, hey, it went out a week ago. They had the receipts and everything. But when this arrived, somebody had cut a hole in the box, very carefully removed the contents, it appears, and then sealed it back up. And then, of course, the thing magically appeared within the shipping company's system after we started asking questions. Well, you can form your own conclusions on what happened. I don't have a proof as to who the guilty party is. I don't think it was the company that I bought the metal from, but it's unfortunate that I'm not going to be able to deal with that company again because they're somewhere in the shipping chain. It's clear that things just aren't getting through, and there's other places I can go that don't have that problem. So it's rather unfortunate, but anyhow, this delayed me in getting a little bit of the metal that I needed to finish this project. I've mounted the adapter onto the mill just loosely, and I'm going to bring you in closer so that you can take a look and we can see what some of the last steps that I have to do are. So I have the adapter plate mounted, 3 studs, 3 nuts. One of the things I noticed is that the flanges on the nuts actually overlap the radius that I had turned on here, so I'm going to have to go and mill that out a little bit, and we'll do that in a few minutes, mount it on the rotary table, basically eyeball things and get that cut through. We do have the studs that are going to actually hold the slotting head on. They are fit in here, they work nicely. All they required was a little bit of a grind, and they fit in there very well. The last thing I'm going to have to look at is what am I going to do and put in here as an adapter to turn the slotting head drive. And I thought of a couple different ways to do this. Thought I had a really good idea. One idea was to just put a Morse taper adapter in there and have a pin. That would involve a little bit more turning work. But my number 4 Morse taper adapter is too long, and I've got a number 3 that would work, but looking at it, I think that's just a little bit thin. So what I'm going to do instead is I'm going to take this old beat up 1-inch end mill adapter and see if I can't cut it down to length and use that. So we'll get on to that a little bit later. But the first thing I'm going to do is get this off and just relieve a little bit of this radius. We'll be doing that on the rotary table using the vertical head on the milling machine. So let's get it set up and get to it. Some of you may remember that when I had this clamped to the rotary table to mill these 3 slots, on the one cut, the part shifted a little bit. And I need to make sure that doesn't happen again. What I learned from that is to make a centering plug that I could drop down in the middle to keep this from turning. Had an engineer that working for me at work this week. He made a small mistake, just a little administrative thing. And he was a little upset about it, and I said, hey, people make mistakes, you learn from them. And I don't mind people making mistakes as long as nobody gets hurt or nothing serious gets damaged. but I do encourage people to make different mistakes each time. Making the same mistake over and over again doesn't help. So what I'm going to do here is I'm going to center this up, and I'm going to drop the plug down in the middle and get that placed onto the table. And then now I'm in a position where I can go clamp the thing down. So get some clamps on here, a couple step blocks. That should do the job. Now what I'm going to do is I'm just going to take this little slot cutter and set it up, come in here from the underside and go back and just take a little bit out of the radius. The diameter of this is a little bit larger than the diameter of the nut, so it should work fine. And do that. I'm going to hold it with an ER40 collet. Make sure I have enough extension. I'll get the mill set up. Okay. That is in place. Now all we need to do is get this position to do the cut. I'm going to do this basically by eyeball. That should be a good place. Let's start at the machine and do the cut. So that was a success. I now have clearance for the nut, and what I'm going to do now is I'm going to mount the thing back on here. But first thing I'm going to do is put the holder in there so that I can get some measurements and see how much I need to take off the end of this thing. Make sure that everything's going to line up and work. Good morning, I'm back. It's about -6 degrees outside for the Celsius folks. A little bit of snow on the ground. I guess I'll see the grass again sometime in April or May. It's a week later than when I started this video. A couple things happened at the end that were a little bit frustrating. I was going to take this Cat 50 taper and turn the end down on it, shorten it up so I could use it in the drive mechanism. Discovered this is not a Cat 50 taper. This is a BT taper. The primary difference is the thread in the back is metric. So one choice would have been to go and make myself another drawbar. I didn't want to take the time to do that, and I didn't want to have a whole lot of threading as part of this video series. So what I did is I got onto eBay, started searching around, and I found an NMTB 50 taper that I can use. It's probably even better. Nice large diameter hole in the end. And so I'm going to install this on the milling machine, see how much I need to reduce this down. My rough guess is that I'm going to have to take this whole end piece off here, but I'll still have this screw for holding in the drive plug. So I'm going to get this fit up. I'm going to put things together onto the mill, take some measurements, and then we'll move over to the lathe to do some cutting. So that's the plan for today. So I'm just going to put this in finger tight for now. It just doesn't need to be a firm. One thing you need to know about me is I have nearly an infinite amount of patience, and unfortunately I've used it all up on something else, so there's not a whole lot left over. So when I hit a little bit of frustration like I have right now, I'm really missing the fact that I don't have a big giant glass window in this shop that I can throw something through. So I don't have that, I can't get it out of my system, so we're just going to have to move on. This, although it looks like an NMTB taper, has a metric thread. It's a 24 millimeter by 3 millimeter, and that's the same as the other one that I was working with. I don't have a drawbar for that. Fortunately, I have a piece of steel that's just long enough. So what I'm going to do is I'm going to put a metric thread on one end. I'm going to keep with inch threads on the other end. I'm going to have to make the hardware, the nuts at this end. But it looks like I'm going to be spending some time in the lathe today that I was hoping to avoid. Once I get that done, then I'll be able to mount this and get back to this project. But at the moment, we're going over to the lathe and we're going to chase some threads. Some metric, some inch. Let's get to it. So I have the rod in the chuck. It's a 1-inch diameter rod. We actually measure it, it's a little bit under that, it's 25.35 millimeters. For 24 by 3 metric thread, major diameter needs to be down in the range of 23.6 to 23.9. So we're going to take about 0.55 millimeters off of this and bring it down into the range of 23.8, give or take a little bit. And I'm going to just go through. I've got my dial set on 0, so I'm going to use the cross slide to come in, or the compound, excuse me, and just touch off on this, and then I'll do this probably in 2 cuts, just so that I can get an intermediate measurement to verify where I am on this, because I've got one shot at doing this. Nice thing about this lathe, I can set it up for inch or metric cuts fairly easily. It's just a matter of shifting a lever. Right now I've got an inch feed on it, coming down, we'll get the outer diameter done, and then I'll convert it over for a 3 millimeter metric thread. So might as well get moving on it, make some progress. So, 1 And as expected, I have about 0.55 to go. .75 is well within the range between 23.577 and 23.952, which are the limits for the thread. So it's right in the middle. I'm happy with what that is. So I'm going to cut a chamfer here. I'm going to cut a clearance groove for the threading tool. We're looking good, 3mm. So this lathe has a imperial lead screw. It's 4 threads per inch, so I'm not going to be able to use the thread chasing dial to just continuously engage for each one. So what I'm going to have to do is come down, and then I'm going to have to reverse the lathe to back out and start all over again for each successive cut here. So you're going to see some going back and forth on this. I'll be bumping the speeds up and down to do that, just to speed the process up a little bit. But that's just going to be a necessity on getting through this, not being able to engage and disengage the thread chasing on this. So it'll go a little slower than it would for an inch thread, but it's still a fairly straightforward process, and might as well just go do it. Now the reason I'm going slow is because when I stop here at the end, I have to allow for the chuck to coast, and if I was going at a high speed, it would continue on and coast a lot farther. But when I'm feeding back out, I don't have any constraints like that, so I basically rush things. Each time put the cross slide back, dial in a little bit more cut. Starting to see the shape of a thread on here. take a test run and see how we're doing. Okay, can live with that one. This one's a little bit tighter, but I think that's just cutting the threads. Certainly not a problem. It's not an overly tight fit, so it looks good. Okay, I'm just going to take a file to the edge of these, flatten the tops of the threads off just a hair. It should be done. You notice I'm filing left-handed. That's the way the book says to do it. I'm not completely ambidextrous, but there are certain things that I do left-handed. I'd be a lot more comfortable filing right-handed actually, but this works for me. And we are done with the thread on this end. Part 1 done. Let's move on to part 2. Part 2 is just this nut right here. Need to make a copy of it. And this one, of course, I can't take off because this is permanently affixed. But I will take a couple measurements on this, duplicate it on here. The only measurement that really is critical is this diameter. I can see right now it's 1.49 inches, so it's just under 1.5 inches. This is going to be for a, I believe, 1.25 inch thread. Yep, and probably just get some overall lengths in here. That's going in about 3/4 inch. So I'm going to drill this out. This is going to be drilled so that I can tap it for 1'8". I'll make this nut. I will also make an end nut to go down here as well at the same time. And so let's go ahead and get to it. So using the original as a template, I'm going to go in about 3/4 inch. So I'll face that off. I'll go about 3/4 inch. I've got a flange, looks like it's another quarter, more or less. The nut itself is about a half. And none of these dimensions are thousandth of an inch critical. The end nut on here, it's a little over an inch. I'm going to make it 1 inch there and allow a little bit more room. So I need to come down to about this distance for cutting off. So, first thing I'm going to do is I'm going to move this out a little bit. Room to work. And so the operations, I'm going to face this here. Let me see if I got the right size of clearance here. I believe this was previously used. Yeah, that's this. That'll be fine. It holds fine for threading. I'm going to face this off. I'm going to turn this down to 1.5 or about 1.49. Then I'm going to drill it down to this depth, okay, or a little bit more, so that I can tap it all the way through. I'll take it over to the milling machine. I will put a hex on here, okay, then I'll bring it back to the lathe, cut it off. So that's basically the plan. We might do the bandsaw and the cutoff, haven't decided yet. And I want about 30 thousandths more. Before going to the mill, I'm going to tap the hole. So I'm back over at the milling machine. Here's the plan. What I want is 6 faces on here so that I can put a wrench on it, basically making a hex head for like a nut. I've got an 1.5 inch cutter in here, and that'll allow me 3/4 of an inch for each one or whatever I decide. So what I'm going to do is I'm going to make it come up, lift this up until I touch off, set the DRO, and then I'm going to make light passes going around here because I don't want to spin this inside the chuck on the super spacer. Super spacer set up for 6 sides. I'll make several passes around, and when I get down near 1¼ inches, which is the size that I want to finish up at, I'll take a measurement and then do a final cut. We'll then take this piece out, I'll cut it off, probably on the horizontal bandsaw, and then take it over the lathe and do a couple final touch-ups on it at that point. So that's the general plan. Might as well get moving, get at it. Here we go. It's going to get a little noisy once I fire up all the machines. Now with my precision measuring instrument, I will confirm that those are in a place that'll work with this wrench. And really, that's all I'm after. Okay, so we'll take this off of here. I want to do a little bit of turning on the lathe, clean up a couple of edges here, either part this off or cut it off, cut a piece off here. Probably do this in a couple steps, but at this point it's just a little bit of cleanup, and I'll probably just rush through that off camera. So let me get to it, and we should be right back and then start putting things together and see if we can actually get back to what I was supposed to be doing hours ago. So I've mounted the holder, and I just need to see how much I'm going to take off, where it is with respect to this lip and so forth. Probably right around where that lip is. So going on to the adapter, I can measure in here, just using a tool bit as a straight edge. I see I've got 2 7/8 inches. To mark that off easily on the other, set a surface gauge, 2 7/8 inches to the same amount. Take a Sharpie, leave a mark in here, and then just run my surface gauge right up against face and make a mark. And so that's because this surface is flat against here, so I need to turn this down to that mark. So I'll take that out, take it back over to the lathe, get to work. Let me explain what I'm going to do. This diameter is 3 inches, the inside diameter of the adapter is 3 inches, so I need to go down a little bit smaller than this, knock 50 thousandths off or something like that. And that needs to occur down to a point that is approximately right here. But what I'm going to do is not worry about getting it to the exact point. I'm going to bring it all the way down until it is just above this mark here. And that way I'll know that I have plenty of extra room. And I'm going to use high-speed steel because this is going to be an interrupted cut, and the high-speed steel is free for me. Not really free, but I've got enough to last me my entire lifetime, so I'm not too worried about it. And it takes the abuse a little bit better than carbide. So I'm going to just come down through here, and probably won't even get as deep as the threads on this when I do it. Once I'm finished with that, I'm then going to take the whole thing and chuck it up, and then from this point here, I'm going to basically just cut it off. I can actually come out to some point in the middle of this threaded hole, but I don't want to stop there. So I'll probably just go just to the inside edge of it. So I have a little nose here that will stick in a little bit into the narrow part of the bore of the adapter, and the rest of it will be out in the wide part of the bore where there's plenty of room. I'll bring this down, I don't know whether I'll go there, maybe a little bit more. I'm just going to see how it looks while I'm doing it. Not too worried about the fact on this that I'm going to have partial threads. It's a pretty deep, maybe a 1 inch deep set screw hole, so the couple threads on the outer end being bunged up a little bit aren't going to worry me. Okay, so I've got a center to guide it, drive it from the small end. Try to take light cuts because I'm driving on a small diameter up against a large. And let's see, I'm doing about a 3 inch high-speed steel. This is kind of hard right here. If I were going 100 feet per minute on that, 4 divided by 3, it'd be about 130, 120. I'm going to cut this pretty slow. I'm going to start it off maybe at 85 RPM and just see how it works. And I'm going to start with a couple light cuts out here to play with. So that's the plan. Let's get to it. Bit harder than I thought. We'll go to carbide. And when I go to carbide, I can bump the speed up a little bit. So try 185. Well, I'm certainly breaking a lot of carbide and not making a lot of progress, so I'm going to stop for a little bit and think about this.